Hello, everyone, and welcome to Science and Society, Our World, Our Well-Being, Our Future. I'm Dr. David Lindberg. I'm with my co-host,
Sam Kephart. Welcome to the show.
Please visit Science and Society online at scienceandsociety, all one word, .net. Welcome back to Science and Society. I'm Dr. David Lindberg with my co-host, Sam Kephart. Our first guest is Dr. Kim Griest, professor of physics at the University of California in San Diego. Dr. Griest trained originally in particle theory, studying supersymmetry, before turning to cosmology and the particles coming out of the first nanosecond of the early universe. Currently, Dr. Griest works on gravitational lensing as well as dark energy, and he serves as chair of the science definition team for the NASA DOE Joint Dark Energy Mission and as a member of other NASA satellite mission teams. Dr. Griest has published over 150 scientific papers. He's a fellow of the American Physical Society, and he's won awards including the Alfred P. Sloan Fellowship, the DOE Outstanding Junior Investigator, Cottrell Scholar, R&D 500, and Chancellor's Associate Award for Excellence in Undergraduate Teaching. Please welcome Dr. Kim Griest. Kim, thank you so much for being with us today. Well, can we first talk about dark matter?
Okay, well, it's a surprising fact of modern science that most of the stuff that makes up the universe, we don't know what it is. And that's pretty amazing given how much we know, that the dominant substance of the universe, we don't know what it is. You look up in the sky, you see stars. Stars form into galaxies. You can see planets. You can see dust. You can see so many things with all of our modern equipment. But you can't see the stuff that's 5 times more. The dark matter is 5 times more than all the other stuff out there. And how do we know it's there? Well, like if you look up at the Milky Way of our galaxy, you can see like 100 million stars, and they're all going around in a big whirl,
right?
A big spiral galaxy. If you use the laws of physics to calculate how fast those stars should be going to hold themselves together, how strong the gravity is to hold them together, you discover that they're going way too fast. In fact, you discover that unless there's dark matter, all the stars in our galaxy should be flying out of the galaxy. And it's not just our galaxy, it's every galaxy. So we know that there's 5 times more stuff out there. We see the gravity of it holding things together. So, but we don't know what it is. We have no, at this point we have some ideas, but we don't have any proof of what that mysterious substance is.
Well, let me ask you this, Kim. We can imply that it's there because we know the laws of physics, and we know that if the stars are circulating at a certain speed, then there's obviously something else there. But why can't we see it? What is so hard about detecting this dark matter?
Well, it's actually not that surprising, because what do you see? You see stars. Stars are huge, bright, shining things.
Right.
Almost anything else you think of is not going to be so bright. And so what it's really saying is that most common substance of the universe is just not giving off a lot of light. So it's dark. And it's thousands of light years away most of the time, so it's not easy to see it. So we don't actually know what it is, but there's lots of ideas of what it could be. You know, I mean, if you just take dim planets or black holes or elementary particles that haven't been discovered, they could all be the dark matter, but they wouldn't be visible directly from our telescopes, which only see light.
Kim, thank you. And again, I apologize for our in-studio technical issues, which apparently are resolved now.
Oh.
Kim, could you talk to us about WIMPs and MACHOs? I mean, these are really colorful acronyms. What do they mean to us?
So the big problem is, what is this dark matter? We know there's a lot more of it than atoms and stars and everything we're made out of, but we don't know what it is. And so the only way you can proceed is by trying to think of some idea and then do an experiment to see if it's there or not. And so the 2 main categories of things that people came up with that might be possibilities are the WIMPs and MACHOs. WIMPs stand for weakly interacting massive particles. They're particles coming out of the Big Bang. We have atoms came out of the Big Bang and neutrinos, and there's all sorts of particles that came out of the Big Bang. Maybe some of these are not visible in our telescopes. And if this is true, it would be fantastic. It would be very interesting. Our bodies would be full of these particles flying all throughout the galaxy, and those are WIMPs. Alternatively, people said with astronomers, and so the particle physicists love WIMPs because they're particles, some kind of exotic particles. The astronomers said, wait a minute now, why do you have to invent some weird new particle that's never been discovered? Why not just say it's black holes or dead stars or stars that are dim or planets, some kind of massive compact halo object MACHOs, that sounds much more reasonable to us as astronomers. And so it was kind of, which one was it, WIMPs or MACHOs? And then there are other ideas too. Maybe the laws of physics are gone. Until we find out what it is, we really don't know what it is.
Kim, thank you. And am I understanding the overall methods, have MACHOs been ruled out as a possible source, or are they still in the running?
So a few years ago, they were all in the running. And in fact, I was working on detecting WIMPs, and when I saw some ideas about how to detect MACHOs, black holes and things like that, and I thought those ideas sounded really good. So I did some work on that subject, and then I joined an experiment, and so we went out and searched for MACHOs. We actually said, okay, suppose there are black holes which make up this mysterious dark matter. How could we detect them? And we actually did the experiment, and we found some, but not enough. And so we managed to prove that the dark matter is not made entirely of MACHOs. And so that's the way it works. You can't actually, you can only rule out the thing you can see. We had no sensitivity to WIMPs. Right. There are now experiments looking for WIMPs. They haven't found anything yet. But so we've kind of ruled out any kind of massive compact halo object being the primary dark matter. There could be some of them out there, but not the primary dark matter.
Kim, I'm curious. I live up in Spearfish, South Dakota, which is just a few miles away from the Homestake Dussel project, and I was wondering, does the Dussel have the prospect of being able to help with the WIMPs and some of this gravitational lensing issue?
Absolutely, with the WIMPs. Nothing to do with gravitational lensing. My experiment with gravitational lensing, we use telescopes to find, how do you find a black hole? How do you see it, right? Well, I can talk about that in a second. You can use gravitational lensing to do it. But the Homestake mine, that's like a mile underground. If you want to find WIMPs, the problem is that they're weakly interacting massive particle, and that word weak is not there by mistake. They're very weakly interacting. They go right through the Earth without hitting it, 99.999% of the time. And so if you actually try to detect one, they will very occasionally hit an atom, a nucleus, and just kind of bump it, just a little jiggle. And if you're sitting up here with all the light from the sun and neutrinos from the sun and everything bumping into you, there's no chance of detecting that tiny little bump that happens every, once in a very rare time. So what they do is to go deep underground, Homestake mine, where there's no light getting down there, there's no cosmic rays hardly getting down there, and the hope is that the WIMPs will come down there. And so I actually have friends not at Homestake but in other mines that are instrumenting up these kilogram-sized blocks of germanium and silicon, and they look for these little tiny bumps. And they're getting more and more sensitive, but they still haven't detected any of that, except for one Italian group that nobody believes.
but it holds great promise, is what it sounds like.
What?
It sounds like you believe it holds promise to do this.
Oh, I think, since our experiment ruled out black holes, planets, and dim stars and dead stars as the primary dark matter, what's left? Okay? And so WIMPs are the main thing that's left, so I think it holds great promise. I think we're likely to, they build these the particle experimentalists build these huge accelerators to detect these particles, create them, at CERN in Geneva and in Fermilab. Well, the first detection in my mind could come in a place like Homestake Mine, where you're going to see the ones that were created by the Big Bang and are still around and are the dominant particles in the universe.
Wow.
It's the ultimate Copernican revolution. We're not only the center of the universe, and we're not even made of the dominant stuff of the universe.
That would be pretty exciting discovery.
It would be great. And that's what I started on, and then I kind of took a deviation off to MACHOs because I said this is a lot easier.